Question 6. A car and a train move together along straight parallel paths with the same constant cruising speed of 25 meters per second. Initially they're side by side. Suddenly the car driver notices a red light ahead and slows down with a constant acceleration. Okay. So let's set this up with a little diagram. Let's say they're both starting with 25 meters per second. Here's the train, which just keeps going at 25 meters per second, but the car has this segment of its motion, which we'll call segment 1, in which it's going v sub 0. Initial velocity is 25 meters per second. The final velocity is 0, because it goes until it stops, and the acceleration during this period, 1, is negative 5 meters per second squared. Then the car remains stopped for 15 seconds. So let's call this segment 2, v equals 0. This t2 is equal to 15 seconds. Then the light turns green. The car immediately begins speeding up, so we'll call this segment 3. The car has initial velocity 0. Final velocity is when it gets back up to 25 meters per second. And the acceleration during this segment 3 is equal to plus 5 meters per second squared. And you're asked, how far behind the train is the car after it has reached its original speed again? So the train will travel some distance, and the car will travel some distance, and you're asked to subtract. So let's look at these 3 segments of motion of the car again. The time for the first segment is going to be the change in the velocity divided by the acceleration. So this will be 25 divided by 5. So t1 is going to take 5 seconds. And the distance that it travels, d1, is going to be equal to the average velocity times the time. The average velocity being equal to the initial plus the final divided by 2, all times the time. The initial is 25, the final is 0, divided by 2, all times 5 seconds. So during that amount of time, multiply that out, I get d1 is 62.5 meters. Okay, so that's segment 1. If we look at segment 2, the distance there is just equal to 0. If we look at segment 3, the time, again, is equal to delta v over a. So that's going to be the same thing, 5 seconds. So this is the time for segment 3. The distance for segment 3 is again equal to the average velocity times the time. And the average velocity in this case is going to be 0, is the initial velocity, plus the final velocity is 25 meters per second. Again, divided by 2 to get the average, and you multiply by 5 seconds, you'll see that numerically d3 is equal to d1, 62.5 meters. So the total distance that the car travels, d car, is equal to d1 plus d2 plus d3 is equal to 62.5 plus 0 plus 62.5. So that equals 125 meters. That's how far the car travels. The train, during that same time interval, will be d train will just be equal to the velocity of the train times t1 plus t2 plus t3, the total time elapsed. So this is equal to 25 meters per second times, the times were 5 seconds plus 15 seconds stopped plus 5 seconds speeding up again. It was 25 seconds total times 25 meters per second equals 625 meters. Is the distance the train traveled. But the question asks, how far ahead is the train of the car? So d train minus d car is equal to 625 minus 125, which equals 500 meters. So let's scroll up and see if that's one of the answers. We see, yes, it's